Today we're going to talk about solving quadratic equations using the quadratic formula. Some of you will probably be familiar with this from Algebra 1 and remember how to do it. But for those of you that don't, the first thing I want to start off with is showing you the quadratic formula and giving you a way to go ahead and memorize it. You must memorize it because it will not be given to you on any of your tests, your EOC, or your ACT.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So now that we have listened to the song, I want to show you how we actually put it into practice. How do we plug things into the quadratic formula so that we can solve any quadratic equation that is given to us? The very first thing that you have to make sure that you do is set your problem up in standard form. ax squared plus bx plus c equals 0. That means your quadratic term, your squared term should always come first, then your linear term, then your constant equal to 0. After you've set things up in standard form, you are going to identify your A, your B, and your C. These will only be the coefficients, but they will include the sign that is written in front of each of these numbers. So in this case, my A value is 2, my B is -7, and my C is -9. Once you've identified these numbers, then you can start plugging them into their respective places. Notice that they've used parentheses, and I'm going to strongly encourage that you use parentheses also. This first parentheses holds a B, so I'll put -7 into that parentheses. Underneath my square root, I've got B squared, so -7 will go here also, an A, and a C. And in the denominator, it is 2 times A, so I'll put a 2 in this parentheses. Now, one of the things that I wanted to show you, a lot of times people think, oh, this is great, I'll just stick the whole entire thing into my calculator and solve. But you can't do that. If you try to stick all of it into your calculator, you are going to get an error. The only part that you can actually stick into your calculator are the numbers that are underneath the radical. And I'm going to pull up a calculator just so we can see how this looks. You will not put the square root into your calculator. I would enter these numbers exactly as you see them here and include those parentheses. So I would do my parentheses, -7, close the parentheses, raise it to the second power, and then I would have -4, parentheses, 2, close that parentheses, parentheses, -9. Close parentheses. You can see it looks identical. Then I'll hit enter. This tells me what is going to go underneath the radical. So I have x equals a -7 is +7 plus or minus the square root of 121 over 4. Now this particular square root is perfect. And if you have a perfect square, the square root of 121 is 11. When you write down the answer, the radical goes away. So I have 7 plus or minus 11 divided by 4. Now, when there are no longer any radicals in the problem, this is a problem that I can actually go ahead and solve, and I'll get 2 answers. So I'm going to break it into 2 parts. The first one would be 7 plus 11 over 4. And the second would be 7 minus 11 over 4. Now again, you can use your calculator to do this also. And I want to show you something. If you ever need to put a fraction into your calculator, if you will do alpha y equals enter, you're going to get a fraction bar that comes up. You can put 7 minus 11 on the top, and you can put 4 in the denominator. Here's the advantage to actually putting the fraction bar in your calculator. Oops, I did the second one. 7 minus 11 over 4 does give me -1. So let's do the top one. Alpha y equals enter. 7 plus 11 divided by 4. Now, this is what I was talking about a minute ago. Here's the advantage. If you use the fraction in your calculator, it is going to give you your answer in fraction form. And I've told you before, we always want to keep our answers in fraction form, not decimals. So there's my 2 final answers. Now, I'm going to go ahead and close down the template, and I'm going to focus just on the problems, and we'll work it out. But we're going to use the same method. We're going to start off by making sure our problem is set up with a term, a b term, and a c term in the correct order, set equal to 0. We're going to identify our a term. In this case, it's 11. Our b term, which is +8, and our c, which is -24. After we've identified, then we're going to set up our problem. So we've got -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now this is definitely some large numbers. I don't think I can do that in my head, so I'll pull out the calculator. And I'm going to put these numbers, just the ones underneath the radical, into the calculator. I'm going to use the parentheses exactly as I see them here. Once I do that, I'm going to find out, actually I should put my x equals. I'm going to find out that I've got -8 on the outside, plus or minus, and I'll have the square root of 1,120. And that will be over 22. Now 1,120 is a large number. I need to break that down and see if anything comes out. You can try doing a square root, but it's going to give you a decimal answer. And when you get a decimal, that lets you know it's not a perfect square. So 2 will go into 1,120 560 times. 2 goes into 560, 280. 2 into 280 is 140. 2 into 140 is 70. 2 into 70 is 35. And 5 goes into 35 7 times. So what will come out? Let's look for things that show up twice. I have 2 2's that will come out of the radical. When I multiply those together, that gives me a 4 on the outside. I have a 2, a 5, and a 7 that remain inside. Remember, these 3 numbers are going to multiply together. 2 times 5 is 10. 10 times 7 is 70. And all of these are over 22. Now I've simplified my radical, but I'm not done. The last step, I need to look at the 3 outside numbers. If these 3 numbers have something in common, I can divide it out of all 3 of them. They do. They're all divisible by 2. 2 divides into -8, -4 times. 2 goes into 4, 2 times, and 2 into 22, 11 times. So my final answer is -4 plus or minus 2 square root of 70 over 11. Number 3. One of the things you might notice about this problem is that we have a negative coefficient. And in the past, if we were factoring or if we were doing completing the square, we could not solve this problem with a negative coefficient as my lead coefficient. So Can I do it with a quadratic formula? Yes. As a matter of fact, it doesn't matter if your individual terms are positive or negative. So I can write this as negative 2v squared plus 2v minus 2 equals 0. And then I'll identify my a term, my b term, and my c term. A in this case is negative 2, b is positive 2, and c is negative 2. So now I'll set up the problem. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and this is all over 2 times a. So I've got negative 2 plus or minus. Let's clean up things on the inside here. I've got a negative 4, I've got a positive 4, and if I multiply negative 4 times negative 2 times negative 2, that gives me negative 16. So if I take positive 4 and put that with negative 16, I'm going to get negative 12. On the bottom, I have a negative 4. Now there's a couple things I need to fix. If you have a negative underneath a square root, we know an I is going to come out. And 12 is big enough of a number that I need to break it down. 2 goes into 12 6 times, 2 goes into 6 3 times, and 3 into 3 1. So a2 will come out of my radical, and a 3 will remain inside. So I've got negative 2 plus or minus, a 2 comes out, and an I comes out, 3 remains inside, all over negative 4. Now, we've talked about you look at your 3 outside terms to see if they have something in common, and these do. Something else you need to look at. We're not allowed to have a negative in the denominator of a fraction. So, one of the things that you can do is change the sign of all 3 numbers. Well, since this particular number has both signs, you're not going to see a sign change here, but you will here and here. So this is going to become positive, and this will become positive also. All 3 of these outside numbers are divisible by 2. That leaves me with 1, 1, and 2. Now, when I write this final answer, this first 1 is absolutely necessary. It's a placeholder. I can't not write this 1. But this 1 is a coefficient. It's in front of the I and the square root of 3. So it's implied. It's not necessary to write it. And then all of this is over 2. Number 4. Number 4 not only has this negative lead coefficient, but it also is missing a linear term. So let's take a look at this. If you don't want to have the negative lead coefficient, you are welcome to divide everything through by a negative, and you could write this as 10x squared minus 8 equals 0. That might actually help you, like we had, so that you don't have a negative in the denominator. So in this case, my A is 10, my B does not exist, so it's a 0, and C is negative 8. So when I set up my quadratic formula, I have negative B plus or minus square root B squared minus 4 times A times C all over 2 times A. Well, you can already see I can kind of cancel some stuff out. A negative 0 is just a 0, so it doesn't really exist. And 0 squared is also 0. So when I start cleaning up the rest of the problem, that plus or minus still exists. It means that I have 2 separate answers from this radical. So what is underneath this radical? I've got a negative 4, a positive 10, a negative 8. Well, first off, I know my answer is going to be positive. You could multiply your 4 times 8 and get 32. Multiply it times 10, that gives you 320. Or you can put that in your calculator. 2 times 10 is 20. Now 320 is definitely big enough to break it down. Things will come out of this radical. 2 goes into 320, 160. 2 into 160, 80. 2 into 80, 40. 2 into 40, 20. 2 into 20, 10. 2 into 10, 5. And 5 into 5, 1. So what comes out? I actually have 3 2's that come out. When they multiply together, 2 times 2 is 4, times 2 is 8. So I've got plus or minus. I have an 8 on the outside, and only the 5 remains inside. And this is over 20. Now, just like in the previous problems, before I circle this, I need to check those outside numbers. This time I only have 2 outside numbers, an 8 and a 20. Can they reduce? Yes, they're both divisible by 4. 4 goes into 8 2 times, and 4 goes into 20 5 times. Now my final answer, don't forget that plus or minus, because that's telling me that I have a positive answer and I have a negative answer. If I forget this, I've forgotten one of the answers. But my final answer is going to be 2 square root of 5 over 5. So this is our final example. And you can see I've already got most of my terms over here on the left-hand side, and I've got this negative lead coefficient. Like I told you before, you can use that negative lead just like you got it, but it sometimes creates this issue in the denominator where we have to remember to divide everything by a negative. So if you'd rather just push everything over to the right-hand side, you can do that. And then you don't have to worry about a negative a term. So this becomes positive 4n squared. Don't forget you want to write your linear term next, so negative 8n and then negative 20. That means that a is 4, b is negative 8, and c is negative 20. When I set it up, I have x equals negative b plus or minus square root b squared minus 4 times a times c. And all of this is over 2 times a. Now, like I showed you before, you're going to want to put the numbers that are underneath the radical into your calculator. That would be these. Do not put the radical in your calculator. It will give you an error. On the outside, negative 8 is positive 8, plus or minus. And now when I put these numbers into my calculator, I get 384. In the denominator, 2 times 4 is 8. Now 384, again, that's large enough that I need to break things down. Divide by 2, and that gives me 192. 2 will also go into 192, 96. 2 into 96, 48. 2 goes into 48, 24. 2 goes into 24, 12. 2 into 12 is 6. And 2 into 6 is 3. And 3 and 1 ends this prime factorization. So what comes out? I have 3 2's. 2 times 2 times 2 gives me an 8 on the outside of my radical. I have both a 2 and a 3 that remain inside. They have to multiply back together, so that gives me 6. Now, before I circle my final answer, let's look and see, do the 3 outside numbers have something in common? They do. They're all divisible by 8. Now, very important, let's talk about which of these you have to write and which ones you don't. This first one has to be written. It's a placeholder. If you don't write it, you have forgotten part of your answer. So I've got 1 plus or minus. The second one does not have to be written. It's a coefficient. It's an implied 1 in front of the square root of 6. And then in my denominator, if your denominator is ever a 1, it is not required for you to write either.